Assalamualaikum everyone. You are watching Science with Asan Bandhan. This is our next part of the video. We were solving physics paper 1, question number 6. This question is about magnetism. Diagram 1 shows the ends of two strong bar magnets and the space between the bar magnets. There is a uniform magnetic field in space between the bar magnets. One of the field lines has already been drawn. Complete diagram 1 by drawing 3 more magnetic field lines and labeling the poles of the bar magnets. Okay, so the question says to draw the magnetic field lines and label the poles. So we know that field lines go from north to south pole, and we have to draw several 3 or more magnetic field lines which should be parallel to the line given above. Okay, so this is our answer. And then let's move on to the next part of this question. Describe a method a student could use to show the shape and direction of the magnetic field between the bar magnets. And you may draw a diagram to help your answer. Okay, so this is our question. And we know that to find the magnetic field lines, we have to use a compass, for example. So if this is the magnet, from north to south, you can hold up a compass here where the North Pole would be repelling from here to this part. Okay, and if you hold it closer to the South Pole, then the North Pole will be attracted to it. So using this, you can find the poles of the magnet. Or you can use another method, which is sprinkling up the iron fillings. For example, this is the bar magnet. You have to put a paper on it and then sprinkle up some iron fillings, and it will take the shape of the fill lines. So you can use any of the method which is suitable for you. I think the second one is much easier. So you can write it like this. Put a piece of paper above the magnet, then sprinkle up some iron fillings on it. Then we have to carefully tap on the paper so that the iron fillings are evenly distributed. Then the last mark is on using a plotting compass. Use a plotting compass to show the direction. So the iron fillings will give us the shape. And the plotting compass will show us the direction. Okay. Let's move on to the next part. Name a magnetically soft material. We know that a magnetic soft material is iron and the magnetic hard material is steel. So you can write the answer iron. The number B says a student investigates how the length L of a current carrying wire in a magnetic field affect the size of the force on the wire. The student uses a power supply and keeps the current in the wire constant. They use the same magnet throughout the experiment. Diagram 2 shows part of the student's equipment. Okay, so there is a connecting wire and there is a magnet showing north and south poles. There is a table. List the variables in the table. Students investigation, add one tick to show each row. Okay. So here are some variables: current, length of wire in field, force on wire, magnetic field strength. So we have to tick on which it is, independent, dependent, or control. So we know the length of the wire in the field is changing, so it should be independent variable. And due to the change in length of the wire in the field, the force on the wire is changing, so it is dependent variable. And the variables that we have to keep constant are current and magnetic field strength. Then next part says table 2 shows the students' results. Okay, so length of the wire is increased and the force is also increasing here. Then you have to draw a graph. First of all, plot them on the results grid and draw a line of best fit. Okay, so here are the points given from starting from 0 to 0. So we have to label up the y-axis and x-axis to plot the graph. It is very, you should be very careful. Since this variable is changing at a constant rate, we can put them on x-axis. So here is the x-axis, length of the wire in millimeter. Okay. Then the force in Newton is given at y-axis. Force in Newton is given in the y-axis. Now you have to give up the points on the y-axis and x-axis. So it is increasing from 0 to 30. So we have to get minimum 5. So 5 starts here, 10, 15, 20, 25, 30, 35. Or you can draw it a bit greater by taking 10 boxes for 5 millimeter, which is 5, 10, 15, 20, 25, 30. So there are 6 boxes here. And 0 to 1.92. Okay, so we can put 0.5 as a box. So this is 0, 0.5, 1.0, 1.5, 2.0. Okay, so let's start plotting it. First is 0, 0. Then it is 5, 0.32, 5 and 0.25 is here. So 3.2 should be higher up. 3.2. Then for 10, that is 0.64. So 0.6 is here. 6.4 should be higher up here. Then for 15, that is 0.92. So 15, 0.9 is here. So 9.2 should be up here. Then for 20, it is 1.28. 21.1, 1.2, 1.28 should be above here. Then 25, 1.58, 1.5 is here, so 58 should be up here. Then for 30, it is 1.92. So for 30, 1.9. So then draw a line of best fit. Okay. So this should be the graph that we were looking for. Okay. Last question says, the student repeats the experiment but with a smaller current in the wire. Draw another line on the grid to show the expected results when using a smaller current. So if you use a smaller current and the same length of the wire, then the force should be smaller than this. So the graph should have a smaller gradient. For example, like this. So this is for IV. Okay. So this is our end of question number 6. So let's end our video here. Thank you for watching.